Okay, so last question on the test review, number 8. Because of time in class and the lack thereof, you might want to slow down on this and make sure that you understand. This will, in fact, be on the test after all, so we want to make sure that you are good to go with it. Okay, so these are sum or difference identities, and we're looking for exact values. Okay, so that means you might have square root answers. And of course, without a calculator, you're not going to have decimal answers. Okay, so no decimal answers. Okay, all right. So we've worked with degrees like 30 degrees, 45 degrees, 60 degrees, 90, 120, all kinds of things that are multiples of these on the unit circle. But 15 is a little bit different. 15 isn't necessarily one of the ones that we've memorized per se. And what sum and difference is, we're going to use some of these that we do know the values for in the unit circle. And I'm talking about even the 120, the 135, so on and so forth. You had 150, all kinds of different degrees, 180, and so on and so forth. All of these different ones, we're basically going to try to use 2 of them to help us create a degree of 15 degrees. So for instance, let's use 2 that we've used many times before, and that's going to be 45 minus 30. 45 minus 30 is the same as 15 degrees. So what we're going to do is we're going to use our identities formula chart where it says something like sine of A minus B, or an angle minus another angle. So this is going to be the difference identity for sine. So let's go ahead and go to our identities formula chart. We're going to look at the difference identity. So here's one of the differences, and it's going to be for sine. This is the one that we're looking at. And we're going to replace it with all of this. It's equivalency. So sine, cosine, minus cosine, sine. So it would be the sine of 45 cosine of 30 minus the cosine of 45 sine of 30. And all I did was use the identities formula chart. And it's all of this that we highlighted before that was in orange. Okay? So let's go back to it. It was sine of A. So whatever angle you list as the first one, that's going to be here with sine and here with cosine. Whatever angle you list here as your second one, remember you're subtracting, that will be here with cosine and then here with sine. And remember, you're subtracting over there. So placement is big as far as A goes with A and B goes with B. Okay, so now from here, there's multiplication, here's multiplication, and we're just going to subtract whatever it is that we get here, subtracting whatever it is that we get here. So let's go to sine of 45. So at 45 degrees on the unit circle, the y value, let's go quickly at the unit circle, we're really looking at 45 and 30 degrees. So that's root 3 over 2 from what we have memorized, 1/2, and then root 2 over 2, and then root 2 over 2. Okay, so looking at the sine of 45, we want the y value at 45. So we're going to write root 2 over 2. Now looking at the cosine at 30, we're going to say the x value, because it's cosine, we're going to multiply root 3 over 2. Then we're going to subtract, just like what we have here from our identities formula, the cosine of 45, let me put that in, say, purple. The cosine of 45 is the x value at 45 degrees, which is that root 2 over 2. And last but not least, the y value, or the sine, at 30, which is 1/2. Again, you are multiplying those. So if I multiplied these two, it's like saying root 2 times 3, which is going to give me root 6. So multiplying the numerators there will give me root 6, and multiplying the denominators is just 2 times 2 is 4. And we're going to subtract this multiplication of root 2 over this multiplication of 4. So if I bring this in together as one fraction, I can write it cleanly as the square root of 6 minus the square root of 2 all over 4. Now, please do not mistaken your square roots properties. Yes, we did square root of 2 times square root of 3 was the same as if you were to bring them underneath the same square root and multiply. But if you have two different ones that are subtracting, that doesn't mean you can say 2 minus 3. Okay? You can only do that with multiplication and multiplication only, not the addition nor subtraction, because they're not like terms. So this right here for A would be your answer. Root 6 minus root 2 all over 4. Now let's go to 165. So from all the ones that we've used, we can create 165 by using 45 degrees and 120. So you're going to have to think a little bit out of the box of which two could I choose from all of these that would create whatever it is the angle is here that's given to us. So what we're really looking for is the cosine of 45 plus 120, because that is equivalent to 165. Again, that here is equivalent to 165. So I'm going to erase just a little bit to make room. And now I have the cosine, okay? So the cosine of something, we'll say A plus B. And it's plus because you see, obviously, this addition here. So let's go to our identities formula chart and look for cosine of A plus B, okay? So the cosine of A plus B is right here, the third one. And that'll be cosine cosine minus sine sine. Okay? So cosine cosine minus sine sine. So the cosine of 45 degrees, whoops. Cosine of 45 cosine of 20 or 120. And we're going to subtract the sine of 45. And again, we're just getting this from the identities formula chart as far as the placement of A and the placement of B. Alright, so let me go back to using the unit circle, and I want to find 45 and 120. So let's draw that real quick. Here's 45, and then here's 120. And if I were to write out the points, I know they're root 2 over 2, root 2 over 2, and then 3, 2, 1 half, and then root 3 over 2 for the y. And it's a negative x and a positive y. So now I want the cosine at 45, otherwise the x value, which is root 2 over 2. I want the x value at 120, which is a negative 1 half. Remember, you are multiplying these. And then I'm going to subtract the y value at 45, which is this, root 2 over 2. And then the y value at 120, which is root 3 over 2. Remember, those are multiplying. So this is equivalent to a, be careful, a negative 1 times a root 2 is a negative root 2 over a product of 4. And then minus root 6, just like we did before, over 4, so that you could write it like this, or if you wanted to write it in one fraction, please be careful when doing so. You could write it as negative root 2 minus root 6 all over 4, or, here we go, root 2 plus root 6 all over 4 with the negative out here. Because this negative is very, very important. If you place it here, that means you're going to distribute to either the bottom or both of the tops, making it look like negative and negative here. So I would prefer that you do it like this, but if you are planning on taking calculus next year, this is an alternative form of writing it where they are both equaled to the same thing. Just the way that they've distributed the negative, that's another way of writing it. And that's number 8.